Now let us learn how to explain the monosubstitution of alkanes containing equivalent and non-equivalent type of hydrogen atoms. Okay, first of all, I will show what is the meaning of equivalent and non-equivalent type of hydrogen atoms. Okay, first of all, look at the carbon. Okay, so this carbon only has one alkyl group, so it is primary carbon. So the hydrogen that attached to the carbon is also primary hydrogen. Okay, so same goes for another carbon, which is also only one alkyl group. So it is a primary carbon. So the hydrogen attached to the carbon is primary hydrogen. So you can see that all of them are primary hydrogen. So they are the equivalent type of hydrogen atoms. Now let's look at another one. Okay, for example, for this carbon, okay, it is like this. So it only has one alkyl group, so it is a primary carbon. Therefore, the hydrogen attached to the carbon is also primary hydrogen. Now, let's look at this carbon. This carbon has 1, 2, 3 alkyl group. So when it is attached to 3 alkyl group, it is a tertiary carbon. Therefore, the hydrogen that's attached to the tertiary carbon is a tertiary hydrogen. Therefore, not all the hydrogens are equivalent because it contains primary and tertiary. Now, let's look at what happens if you have equivalent type of hydrogen atoms where it undergoes monochlorination. Okay, so it will use single monochlorinated product. What does this mean? Now, let us look at ethane first. Okay, so when we look at ethane, we know that all the hydrogen is primary hydrogen. They are all equivalent. So when you substitute chlorine, okay, when you substitute chlorine and hydrogen, okay, so what happens is you will get the same product. All of them are the primary haloalkane. Although you can substitute in different positions, but they are the same. Therefore, we say that it is a single monochlorinated product is U. Okay, it is not like I can use primary, secondary, or tertiary. When it is single monochlorinated product, means it's either primary, secondary, or tertiary. Let's look at another example. Okay, let's go for a secondary hydrogen where all of them are equivalent. Okay, for example, when we look at the cyclopentane, okay, so there are 2 hydrogen here, so we know that it is a secondary carbon. All of the carbon are secondary carbon, thus the hydrogen is also a secondary hydrogen. So when it is a secondary hydrogen, when it is substituted by chlorine, it only uses single monochlorinated product. Means that all of the product form is secondary haloalkane. Okay, now I want for you to look at this question. Although this carbon is quaternary, but the hydrogen is attached to a primary hydrogen. Therefore, we still say that all the hydrogen is equivalent. That's why there is single monochlorinated product produced. Okay, now we go for non-equivalent type of hydrogen atoms. It will produce mixture of products. Okay, what does this mean? Okay, first of all, we have primary hydrogen and also tertiary hydrogen. So it will produce tertiary haloalkane and also primary haloalkane. There are mixture of products. Okay, so we no longer say single monochlorinated product. Okay, when we look at another example, you can see that we have a mixture of primary and secondary hydrogen. Therefore, we will also have a mixture of primary and secondary haloalkane product as well. Okay, just now was chlorine. Now we go to bromine. Okay, bromine must be very careful because bromine is less reactive towards alkanes compared to chlorine. But bromine is highly selective in the site of attack when it does react. Okay, so thus a monobromination of propane yield two different bromopropanes. Okay, now the percentage of yield in monobromination is based on the stability of free radical, which we have learned earlier. Okay, now let's look at what is the meaning. Okay, you can see here we have primary, secondary, and primary also. Okay, but the product label major is the secondary haloalkane, and the primary only has 1%. Okay, why is it so? Because we know that secondary, for example, secondary free radical is more stable than primary free radical. Okay, thus bromine is very selective, so it will substitute at the secondary, substitute with the secondary hydrogen. So the secondary haloalkane is the major product. Okay, so this is just the summary. Bromine is highly selective, so there will be major and minor product. Chlorination is non-selective. So that's all for this part.